So this week we're playing with probability. And in my opinion, probability is something we use all the time in our lives, whether we think about it or not. So just some ideas about what I think probability is. And in the book, by the way, this is chapter P. And it's in the back. So I think about probability all the time. For example, a friend of mine says, hey, you want to go out tonight and do something? And I'm thinking, what's the chance my wife will get upset about this or say, yeah, no problem, go out. What's the chance my daughter's actually going to practice piano today when I asked her to the first time? What's the chance that if I take this route to work and I need to get there soon, that I'm not going to have an accident? Or is this intersection safer than that intersection? Can you guys think of any ideas about probability in your life?
What is the probability that this item is going to go on sale in the next couple months? Should I buy it now? Should I wait?
Yeah, my wife has been asking me to research solar panels for a while, and it's like, okay, so they're expensive, but there's incentives now. So what's the probability if I do it now, it's going to be cheaper than in a month? I got to go see my mom in Rhode Island this summer. So when do I buy the tickets? Will they be cheaper now or cheaper in a month? Like, what's the chance, right? So there's all these chance things that happen, and we have these little calculations that go on in our head about it. And sometimes it's like pretty obvious to us. Sometimes we think and it's like, I'm not really sure. Let's see, I had another idea. Oh, like I gotta go, I didn't have time to go grocery shopping this weekend. And I prefer it when it's not too busy, but like, what am I gonna have for dinner tonight? I get out of class at 5. What's the chance the store is gonna be very crowded at 5 on a Monday? It's pretty high, I would say.
Extremely high.
Yeah.
Don't do it, avoid it.
What's the chance I'll get my grading done tomorrow? Well, you have an exam this week, and so I feel guilty if I don't. So I think there's a pretty high probability I'll get it done tomorrow due to the guilt factor there, right? So I can just go on and on listing all these things I think about with chance and probability related to myself and all the things around me. So my idea about what probability is, it's a measure of my belief that something will happen. And so the big question here is, okay, so how do I measure that belief? And sometimes it's really straightforward. Like, I can flip a coin and ask, what's the chance of getting heads? Right, and I'm pretty sure there's a 1 head out of 2 choices, so there's a 1/2. And so when we measure probability, it's usually a fraction, decimal, or percent. So like with the flipping a coin idea, right? I have this idea of how to measure the chance of getting ahead. And as a fraction, it's 1/2. As a decimal, it would be 0.5. And as a percent, it would be 50%. And there's no best way to state it. There's just different ways to state it. There's other things that aren't so obvious. So before we get to some harder questions, let's continue with some easier ones like flipping a coin. My daughter's friend likes to play basketball, and they go out and they shoot hoops together, and she's not as good as he is, and I'm not as good as either one of them. So like shooting a basket, like, what's the chance of getting it in? And at first glance, we might think about it as a coin. Well, it's either a head or a tail. It's either in or out, right? So I have two possible outcomes here. And often, like, we list the outcomes in a set of parentheses. So that's my best attempt at a curly bracket there. And so either it's going to be in or it's going to be out. Kind of like with the heads up here with a coin, either we're going to get a head when we flip the coin or we're going to get a tail. Right? So these are all the possible outcomes. And sometimes it's easy to list all the outcomes in a situation, and sometimes it's not. The question is, are they equally likely outcomes? And I'm going to have to say no on the shooting a basket because I've shot hoops with them before and I get it in way less than either my daughter's friend or my daughter. Right? So my probability for getting it in, so usually we use the letter P for probability, parentheses, in. So that's my shorthand for probability. Getting the ball in, probability, the net. All right, so I'm going to say mine's about 50%. I'm not a very good shot, and that's probably, I'm probably not even 50%. Whereas someone else, like my daughter's friend Nick, Nick's probability for getting it in, his is probably going to be like maybe 65%. He's a better shot than me. And we're both standing at the free throw line, for example. So sometimes probabilities are pretty straightforward. And often when they're pretty straightforward like that, we have an idea called theoretical probability. And in theoretical probability, we basically think we know everything there is about the situation. So, that was messy. Like the flipping a coin idea, right? We think we know that there's a head and a tail, and then we're just as likely to get a head as a tail. So that's the idea of theoretical probability. And a theoretical probability, we have this idea of a favorable outcome, like getting a head, versus total outcomes. Right? And I can just make a fraction. Head, one favorable outcome, two total outcomes. Another kind of probability called experimental or empirical probability. And an experimental probability, we don't know everything. We have to just observe many instances. And in that case, it's kind of similar here. We would just look, okay, how many times did Gary get it in, right? Those are my favorable outcomes. I just count.
Is there a calculation to how many instances you need to view for that? Like, is there like, hey, if there's 20 outcomes, then we need to watch it 400 times or something like that?
That's a good question. And there is no set law or rule about that. It's, and we'll get to that kind of next, but there isn't a rule about that. You just have to make a lot of observations, and then a lot just kind of depends. Like, think about probability in sports. Basketball players that are professional shooting free throws. those percentages they throw out there are just, you know, the lifetime observations of that basketball player on that team or in the NBA, for example. And then other situations, sometimes we can set up the experiments and run them over and over again, but often it's just, we just have to see what information is out there. So we'll look at some examples of that. And computers have aided us a lot in this way because we can simulate these situations. So that's another topic for today. Excellent question. Yeah, so how many times do you have to watch me throw it to say, hey, this is my free throws? Now, the more I do it, you think the better I get, but there's probably a limit to that. So there is a relationship between these two. So I'm just going to give a different definition of probability and then talk about the relationship between those two. And then there's other kinds of probabilities also. So a slightly better definition of probability . Probability is the long-term relative frequency . Or proportion of times an event occurs. So the first part of the definition is basically that experimental probability I just mentioned, and the second part is that theoretical, where we think we know everything about the situation. And those two are related, and that's called the law of large numbers. So the idea is that for me, there's this ideal percentage that's my free throw percentage. And the more and more we watch it, the closer I get to that ideal of what my percentage is. And basically what the law of large numbers says is as you make more experiments, the experimental probability approaches, gets closer to the theoretical probability. And so we'll take a look at a little spreadsheet example of this idea. Like think about flipping a coin. So I flip a coin once, I get a head. Second time, I might get a head again. Third time, I might get a tail. Fourth time, I might get a head again. So after 4 trials, you know, 3/4 of the time I got heads, right? That's not 50%. So the idea of chance, and chance is synonymous with probability. That in the short term, it's unpredictable. Like you can flip a coin and I could guess it's going to be a head, but I don't know. It could be a tail. It's going to jump all over the place. So chance and probability short term is unpredictable. But in the long term, there's a pattern. The more times I flip the coin, the closer I'll see the experimental probability settling into 1/2. And I'm not going to flip a coin 1,000 times, but I can ask the spreadsheet to do that for me. So I'm going to bring up a new spreadsheet. And I'll share it with you if you want to play. So this gets the idea of like, how many times is enough? Well, the answer is we don't really know. We just keep doing it and see. And computers have allowed us to continue. All right, so making this probability sheet. And there's not going to be much to see at first. I'm going to put it in the chat anyway. Copy it. But eventually I have a few examples in here. So let's say in this case, we're counting heads. Fair coin. And fair is that idea of equally likely. And to do this, what I'm just going to do is say a head is a 1. Right? So we'll count it. If I get a 0, it's a tail. So I'm going to use that rand between function I mentioned way back in week 1 and say I either want a number between 0 and 1, and the rand between only does whole numbers, so it's either going to give me a 0 or a 1. And then the probability of a head equals, and then I'm just going to run this a whole bunch of times. So let's go, let's say around 100 times first. And whenever you use a random function like this, it's going to jump around a little bit. So every time you change something on the screen, it's going to redo all the random numbers. And so for the probability of a head, I would just want to count how many ones there are. So to do that, I could just add up all these numbers. So to do that, I'm just going to say, hey, add up everything in column A. And it only is going to add numbers. It's not going to try and add words. And then I want to divide that by the count. How many numbers? So only counts numerical things. It's not going to count those words there. So count everything in column A. And first time it was about to say it was 0.47, now it says it's 0.52. And again, every time I change something on the screen, it's going to recalculate that. So that time it's 0.44, last time it was 0.52. This time it's 0.54. But that's only out of 100, right? So I could fill that down and just do more. And the bottom line for 100 flips, it's going to jump around quite a bit. It's going to be near 0.5, but it's not going to be exactly 0.5. Let's see. Actually, I should be able to control shift and actually drag it down, I think, for this to work. How many rows does, I think Google gives me 500 rows to start. Oh, more.
I thought it was 1,000. Yeah.
Cool. We're going to get about 1,000 coin flips here. And that's probably going to get us a little closer to that 0.5. Okay, so we have almost 1,000 because the first two, we have 998 of them. And notice that it's much closer to 0.5 than it was before. Let's just change things. Ooh, that one's still quite a bit off. So even 1,000, it turns out, isn't quite enough to get us really close to 0.5. Sometimes it's pretty close like there, but the other one was 0.467. So that was a little bit off. So what does the law of large numbers means? It means you got to have large numbers. And is 100 enough? No. Is 1,000 enough? Not necessarily. Is 1,000,000 enough? Maybe. Will we ever get exactly there? The answer is sometimes. Chance is involved, which means unpredictability is always going to happen. So probability is a tricky thing. And in particular, I've just picked some super easy situations. Most situations aren't that simple. Like I was thinking, I have to drive every day, and I've been in a couple of accidents, and they're very frightening. So I like to not get in them. People can get hurt, my car gets damaged, right? All kinds of bad stuff. So probability of a car accident. And there's statistics out there that one is more likely to get in an accident near their home than away from their home. Now, probabilities like this, it's not like flipping a coin where we can just, do it over and over again. We just have to look at the data that's out there. And, finding that data is hard. We're not going to do literal experiments on car accidents. So a lot of probabilities are personal or subjective, or just difficult to get data on. So other probabilities. Sometimes the probability is personal or subjective. Like, it depends. Like, I'm thinking about going to the grocery store at 5. Is it going to be too busy? Do I want to wait till later? Well, in Pendleton, that's one thing. In Portland, it's another, right? So there's that subjective aspect to it. Other times, probabilities are just difficult to get information about. Some of the personal subjective ones just really aren't directly answerable. We can guess, it's more than 50%, it's less than 50%. But other times we can actually test these with computer simulations. And next week, we'll start playing with some computer simulations for testing probabilities. For now, we're just going to kind of stick with the basic idea of probabilities. Other thing I should mention that I didn't bring up earlier, when we calculate a probability, it can be at most 1, right? 1 with a probability is the same as 100%. That means it has to happen. Probability could be 0, which means it didn't happen or it can't happen, right? So that's possible too. So probabilities have to be between 0 and 1. They could be 1, absolutely must happen or did happen. 0 did not, cannot happen. Okay. So let's look at some other examples of probabilities.